The speed time graph shows an initial constant retardation, which means a negative acceleration of 2 meters per square second for t seconds. Find the total distance traveled in meters. When we look at this question, to find the total distance traveled in a speed time graph, how can we find the distance traveled? That thing we can take and by the area under the graph and the time axis. Area in between the graph and the time axis gives us the distance traveled. Now when we look at this question, now to find the area we need time and the velocities. If you look at the time axis, you can see the time is given in seconds, but it's not uh, it's given in a symbol, no? T, 2t, 3t and 4t. We don't know exactly how much is this one, so we have to first find time to get to the area. So how can we time t here? Now when we look at the question, we can see a data is given. The initial constant retardation is 2 meters per square second. That means in the first 0 to t seconds, the deceleration, the gradient of this one, this line here is 2 meters per square second. So within that time, I will mark these points and A and B. So we can use this retardation to find the T here. So what is that retardation is equal to? You can write retardation. This part A retardation equals to how much? Initial velocity is how much? Initial velocity is 80 at A, at B velocity is 60. Divide by the time taken. Within that, it's going to be t minus 0. So this retardation is 2. Right side we got 20 over t. When we cross multiply and make t as the subject, t equals to 20 divided by 2, which means 10. So what are the units? It will be the 20 is in meters per second and this 2 is in meters per square second. So it will end up in seconds here. Now we found t, values of t. This will be 10 here, 2t means 20, this is going to be 30, and this will be 40. Now we can separately find. Now I will mark these regions 1, 2, 3. Now these three regions you can separately find the areas. If you consider the region 1, what is the shape? We can see the shape as it's a trapezium. How to get the area of part 1 equals to, what do we do? How to get the area of a trapezium? You add the parallel sides, 80 plus 60. You add the lengths of parallel sides divided by 2 and multiply with the perpendicular distance between them. The perpendicular distance is 10. So when we solve it, we get how much? We get 140 divided by 270, 70 into 10, 700 meters. Similarly, how to get the area of the section 2? That area we can take by time. This is rectangle, easy. Length into breadth. So the height of this one is equal to 60 and the time in between is 10. So 60 into 10 equals 600 meters. And part 3 area, how can we take it? Part 3 area is equal to, we can take that by, what do we have here? It's a triangular shape. If you notice, what is this shape? This is a triangular shape and it's a right angle triangle. Pretty easy to find the area. So it's going to be half into length or the base length. Base length we can take from 40 to 2t to 40. That means 20 seconds. 20 seconds into perpendicular height. Perpendicular height is 60. What do we have here? Again we got 600 meters when you solve it. So the total distance traveled equals the combination of all these three areas. So total distance I can write equals to how much? It's going to be 600 plus 600 plus 700, which is equal to 1900 meters. Now, when we look at the part B, they are asking the deceleration at 3t second. That's a good question to ask. Deceleration at 3t. That means at this exact moment, what is the deceleration? How can we find it? Now, for a given moment, we actually yet we don't know how to find the deceleration, but for a given time period we can find it, no, from that 2t to 40 we can find it. So that same deceleration will apply for every moment on this number, this straight line, this portion of this straight line. What we have to do here is find the deceleration or the retardation from 2t to 40, that will be the same as the deceleration at time tt, 3t. So we can take it, and the deceleration is equal to, deceleration is equal to how much? The speed difference over time, speed difference over time. So speed difference, what is the speed difference? Initially it is 60 and final here it's going to, the speed is going to be 0 divided by total time taken. What is the total time? 40, here we know 20, 40 minus 20, what do we get? We get here 60 divided by 20, which is 3 meters per square second. Now something important here, some of you might have taken this way. If you find the acceleration for this part, you can get the answer in this order. You will write it as 0 minus 60 over 40 minus 20. Now what do we get? Now this is the corresponding way, no? This is the standard method of getting it. Now you will get minus 3 meters per second. So can we accept both answers? Yes. Here I use the word deceleration. So if you are using the word deceleration, you don't need to find the negative value. But here when I apply it in the standard order, I get minus 3. Minus acceleration means it's going to be a deceleration. Okay. Now for the part C, what are they asking? Part C, they are asking to find the average speed of the whole journey, including steps in meters per second. So we can take the average speed by, what is the equation for average speed? Average speed is equal to total distance divided by total time. So total distance, what is the total distance here? Total distance travel we found in the part A, it's going to be 1900 meters divided by how much? Total, they are asking to including stops. When we include the stops, it's going to be what? We have to consider in this one we can't see any stops, no? Because in each case there was a speed, that means we don't have any stopped areas. But anyways, what is the total time taken? It's 40 seconds. So it's going to be divided by 40 here. So what's the answer? What is the answer we are getting here? It's going to be 47.5 meters per second. Average speed is going to be 47.5 meters per second.